If you put it simply, a smart material is a material that responds reversibly to its environment. However, in smart materials we tend to look at materials in a system sense. So we might look at smart systems like sensing, like structural health monitoring. We consider that to be smart. So, it depends that's how I look at smart, in terms of systems and in terms of materials themselves. Well, the Materials KTN's got smart and emerging technologies group. If I can split it into two, smart and emerging, because maybe we think of them slightly differently. As I said to you, smart materials is about materials that are smart, and it's also about systems that are smart. A lot of the technology we look at today is smart technology. The things that drive our everyday life, especially the communication side, involve a lot of materials that we would term as smart. For instance, if you look at comms, communications, a lot of it is based on polymers. So if you look at OLEDs, that is semiconducting polymers. Those are smart materials. Yeah? So that is why there is a need for it, because a lot of technology is driving smart materials. The emerging technology is a slightly different thing. That's about looking at things that we might consider will be the technologies that will make changes in a lot of areas. And I mean, we're talking cross-application things here, so they might have an impact in a lot of areas, from defence to the marine industry to the phone industry. And those are the emerging technologies, are things that can potentially make step changes in the way we use things. And it's all really about horizon scanning, looking at the stuff that's coming up that might seem a little bit strange, but you think, actually, that could potentially be have a huge impact. And what I've tried to do there is, depending on what sort of it could be any material. It doesn't just smart materials, it could be polymers, it could be metals, it could be powders, it could be textiles. But if that technology looks like it's really interesting and could potentially have a huge impact, we want to make the community aware of it. Because often, a lot of the ideas, they come from one area and somebody says, I'm using it in this area, and you put it and make it public, and all of a sudden somebody says, I can use that for what I'm doing. And then it becomes a much more interesting prospect. So that's it, smart materials, emerging technologies. They can be the same, but they can be different. As far as what materials, smart materials necessarily that designers need to know about, I think that is a very difficult question, because as a scientist I'm not a designer, and therefore it's difficult for me, because designers tend to think, I think, more laterally perhaps than scientists do. It's difficult for me to pick out something that I think that they might be interested in, because they might be interested in something I don't think is particularly interesting. But I would say that if you want to find out about the huge range of materials that are available, certainly on the Smart Materials website we have a design guide which looks at a whole range of smart materials. But I think to pick ones out, I would focus on some of the emerging technologies that are becoming big at the moment. One of them is energy harvesting. Energy harvesting is a huge topic. A lot of investment going into energy harvesting. A lot of money coming from TSB in energy harvesting. It's a big business, and the big impacts there are things like how do we make systems, micro nano systems work to harvest energy in a whole variety of things, from from powering your mobile phone to powering your laptop to powering things perhaps that are embedded in your clothes, intelligent textiles. But energy harvesting is a big topic. We tend to think about, energy harvesting in terms of sort of piezoelectric type things, which is something that vibrates, creates electricity. But if you think of energy, and I think that's the sort of technology that you'd be looking at, or we might think about in terms of phones and computers. So you're moving them around, and as they move around, they generate power. But the trouble is, how much power can you generate from that? And is it enough to run a laptop? And how can we improve that sort of technology to give us the power we need? So that's really important. The other thing is, how do you take that energy that you're creating by moving your laptop or your phone around and actually store it? Because nobody's really taken that step and said, how do we take harvested energy and actually store it so we can use it later? Because you might be on the train and you're creating loads of energy to power your laptop, but you're not using it, so that energy is going to waste. You can't store it unless you can store it, and that's a really important thing. So that's, I think, one area that's a big interest, and there's potentially materials there that would be of interest. It is about keeping your eye on what's going on in terms of emerging technologies. Now, I read recently quite an interesting story, and like a lot of technologies that actually came out of the defence sector, because the defence sectors, it doesn't matter whether it's in the UK or America, they have a lot of money to spend and they want to do certain things. This one actually related to visual displays in a pilot's helmet. So pilots who fly all these super fast jets have displays that sit in the visor of their helmet, so when they're flying they've got this display in front of them. The problem that the military had was that when a pilot flies from bright sunlight into cloud, or from cloud into bright sunlight, he can't see his visual display because the light intensity suddenly changed, and it needs to be an instantaneous change. He cannot be without that visual display for even a second, because that's telling him how fast he's going, what height he's at, and all that useful information. So a group that was spun out of a university actually came up with a technology, a crystal technology, liquid crystal technology, where the crystals themselves actually respond to the light that's hitting them by changing the light intensity in the display so that it's always visible to the pilot. I think that's a very interesting technology, because I don't think that's a particularly well-known technology. I think another area of materials that would be of interest to designers is perhaps one that relates to some of those science fiction ideas you think about. Somebody actually mentioned this morning in a conversation I was having invisibility cloaks like Harry Potter. So Harry has a cloak that makes him invisible. Now that sort of technology is actually being looked at by the military for camouflaging things like tanks and planes, because obviously they don't want them to be seen. But I think even more interestingly, there is actually technology out there that's been announced that actually involves sound invisibility. Now, sound invisibility, interesting concept. You're thinking where that might be used. Well, I mean, I think the obvious one is if you're having a private conversation with somebody, and a sound invisibility cloak could stop other people overhearing it accidentally. And if it's secret stuff, well, that's quite important. Interesting enough, like a lot of technologies, it's based on polymers. And the idea is that the polymers themselves have different, I guess the easiest way to look at it is different hardnesses. So that some are soft, some are hard. And the idea is the sound resonates off the individual polymers, and by resonating off each other, they actually cancel each other out. So imagine taking a wave and having an anti-wave, and then essentially you end up with nothing. Sound invisibility. Interesting concept. I mean, obviously, the idea is it's probably being developed for the military, but I'm sure there are lots of other applications out there that would be equally interesting for some sort of technology like that.